A stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeters per second. So what they are saying is that when you put a stone into a lake, the waves, the ripples that are formed, are moving at a speed of 5 centimeters per second. So if the ripples, the circles formed are moving at the speed of 5 centimeters per second, that's the rate at which its size is increasing. That's the rate at which its radius is increasing. So that is the rate of change of radius with respect to time, which we write as rate of change of y with respect to x is dy by dx. So rate of change of radius with respect to time is dr by dt. So what they have given is dr by dt is 5 centimeters per second. Now the question continues. At the instant when the radius of the circular wave is 8 centimeters, how fast is the enclosed area increasing? So what they are asking is how fast, what is the rate of change of the area? How fast is the enclosed area increasing? That is the rate of change of area dA by dt with respect to time. That's what we are looking for. So we put it as question mark. Rate of change of area dA by dt, rate of change of area with respect to time is to be found. So what exactly we have to do now is dr by dt is given to us, dA by dt is to be found. So we try to find a relation connecting A and R. So what's the relation connecting A and R? Area of a circle is pi r square. Once I establish this relationship between A and R, I'll say differentiate this relation with respect to t. So differentiating with respect to time t, derivative of A with respect to t will be dA by dt. So I say dA by dt is equal to pi is coefficient which stays there, derivative of r square with respect to t. Derivative of r square is 2r into dr by dt. Into this, I know the value of dr by dt, which is 5. I'm going to sub it in. So that's going to make it 2 pi r into 5, which is 10 pi r centimeters square per second, because this is the rate of change of area, centimeter squares per second. But at this stage, we use the specific value which is given to us. They said the radius of the circular wave is 8 centimeters. That's given that r is equal to 8. So that value of r goes into this at this stage. So when r is 8 centimeters, dA by dt becomes 10 pi into 8, which is 80 pi centimeters square per second. That's our answer. We quickly look at another question. A cylindrical tank of radius 10 centimeters is being filled with wheat at the rate of 314 cubic meter per hour. Find the rate at which the depth of the wheat is increasing. So let's say, so this is the cylindrical vessel of radius 10 meters. So radius doesn't change, but you are pouring water into that. You're pouring wheat into that. So the wheat gets filled in like that. It goes up higher and higher. So thereby the height keeps increasing, but the radius is fixed. So what we are doing here is we are pouring wheat into this cylindrical vessel at the rate of 314 cubic meter per hour. So if you are pouring 314 cubic meter of wheat into this every hour, that is the rate of change of volume. So we say the rate of change of volume, which is dV by dt, 314 meter cubed. And your question is to find the rate at which the depth of wheat is increasing. That's the depth, h. So the question is to find out the rate at which the height is increasing, the depth of wheat is increasing. So dH by dt is equal to question mark. So what I need is a relation connecting these two quantities, V and H, and of course we know a formula connecting them. V is equal to pi r square H, And r of the cylinder is 10, we know, which is fixed. It is not a variable, so I'm able to substitute for r value. So when I sub it in, the only two variables are v and h. I put the value of r in because it's always going to remain as 10 meter. That's the radius of the vessel. So that gives me 100 pi h. So I establish a relationship between v and h. And if you have a relationship between v and h, now I can differentiate with respect to t. So I say differentiating with respect to t, v becomes derivative of v with respect to t, dv by dt is equal to 100 pi is coefficient which stays there, and derivative of h with respect to t is dh by dt. Into this, I know what dv by dt is. So I will replace dv by dt by 314 now. So 314 is equal to 100 into pi is 3.14 into dh by dt. And then I solve for dh by dt. So dh by dt will be 314 by 314, which is 1 meter per hour.